Hi friends, now we are going to discuss about hydrogen bonding. This hydrogen bonding I will make like two videos. One is definition and nature of the hydrogen bonding, and another one types of hydrogen bonds and what are the properties of hydrogen bonds. Okay, because video is becoming lengthy, that is the reason two videos I am making. So now hydrogen bonding, we can say this one H bonding, hydrogen bonding. What is meant by this hydrogen bonding? For example, you see A is an atom is there. A is an atom. Okay. This is bonding a covalent bond with hydrogen and then forming a bond with B. Okay. So here A and B are the more electronegative atoms. A and B are the more electronegative atoms. Okay. So by forming of a covalent bond, this bond, it is forming like the electrons are moving towards a highly electronegative atom. Electrons, more the covalent electrons are moving towards highly electronegative atom. Okay. So here because of that it will gain the partial negative charge and this will gain the partial positive charge. And the same thing here when you are considering, this will give like a partial positive charge, already even hydrogen atom is there, and here it will give the partial negative charge. Okay, so this partial positive charge and partial negative charge we are calling as a hydrogen bond. So how can we define the hydrogen bond? The bond formed between the hydrogen atom and the highly electronegative atom. The bond formed between the highly like hydrogen bond to the highly electronegative atom of the element, and then this hydrogen bond, actually it's a weak bond. Hydrogen bond is a weak bond. The attractive force present between the electropositive atom and the electronegative atom also we can say here. So this is covalent bond, it is forming covalent bond, and this is hydrogen bonding we are representing with dotted line. Hydrogen bonding we are representing with dotted line. Okay, so once again I am repeating the definition. The attractive force present between the hydrogen atom and the highly electronegative atoms like fluorine, oxygen and nitrogen. Highly electronegative atoms like fluorine, oxygen and nitrogen. Other things it won't form the hydrogen bonding. Okay, so for example here you can say hydrogen fluoride molecule is there. Hydrogen is forming a bond with fluorine atom. It's a covalent bond it is forming because of sharing of electrons each other, one electron, and here another hydrogen it is forming, another fluorine it is forming with hydrogen bonding. This is delta positive, partial negative charges, and again this is joining with another hydrogen atom covalent bond, and again with dotted line, that is a hydrogen bonding. Okay, so again partial negative, partial positive charges. Like this we can say here other examples of this we can say like a H2O molecule also we can say the example of this. Okay, so like fluorine, oxygen and nitrogen, why can't we can take the other elements? Like when you are taking the periodic table, especially from 4th A group to 7th A group elements, you take electronegativity values will be increases across the period, right? That we have an idea. So here carbon you take, carbon, nitrogen, oxygen, fluorine you take. So carbon, most of the cases these three are the more electronegative compared to the carbon. And carbon, especially when it is coming to the organic compounds alone, rare cases carbon can involve in the hydrogen bonding. But here fluorine, next you take here nitrogen, phosphorus, arsenic, antimony. Next oxygen, sulfur, selenium, tellurium you take. Fluorine, chlorine, bromine, iodine you take. So electronegativity values will be decreases down the group, right? Electronegativity values decreases down the group. For example, if 4.0 value of fluorine is there, chlorine will be 3.5. Okay, so even why that one? Because of the bigger size. Because of the bigger size, chlorine is not able to, because of bigger size, chlorine not able to form the hydrogen bonding. Even you take nitrogen and chlorine, both of them are having the same electronegativity also. Nitrogen only can form some more hydrogen bonding, but chlorine does not. Why? Because chlorine is having more size, atomic number of 17. With 17 electrons are there. Okay. So this is the reason we can say. And then what we said here, hydrogen bonding, here I shown you like dotted lines, right? Hydrogen bonding is representing with dotted lines. Hydrogen bonding is representing with dotted lines. Okay. So then, what about, for example, if they are giving you like this, you see hydrogen bonding is forming a fluorine atom. Next, hydrogen bond. Okay. Next, you take oxygen, hydrogen bonding. See, one more thing we have to remember here. The first forming bond should be covalent bond. Hydrogen bonding, there is no independent existence. First, it has to associate with a covalent bonding. By forming of covalent bond, only hydrogen bond can form. Directly hydrogen bonding, there is no chance of formation of directly hydrogen bonding. Okay. And then, magnitude of hydrogen bonding is depends on magnitude of hydrogen bonding depends on like you take a solids will be maximum will be there, solids will be maximum magnitude, and gaseous molecules will be minimum. This one we should remember. Okay. So here hydrogen, highly fluorine, hydrogen is forming a bond with a highly electronegative, a covalent, and the hydrogen bond. Here oxygen. So which will be more electronegative usually? So compared to all these bonds, like a HF, we can say HF hydrogen bonding, HF hydrogen bonding, HO hydrogen bonding, and HN hydrogen bonding. Which of the bond will have a more strength? Which of the bond will have more strength here? So this strength, when you are discussing about this, obviously which is having the highly electronegative atom. Which one is the highly electronegative? The electronegativity difference is more here in this case. Okay. In this case, more electronegative value. So here bond strength will be more. Like this we can write. Okay. So which is having a highly electronegative atom? That highly electronegative atom increases the strength of the bond. That is the reason hydrogen fluoride hydrogen bonding will be more. Okay. Next, when it is coming to the strength of the covalent bond, this is one importance. And strength of the hydrogen bonding, how can you say? Like a covalent bond you take, covalent bond. Next, hydrogen bonding. Next, van der Waals forces. So covalent bonding, what we know? Like a covalent bonding, we are not able to break the bond easily. We need more energy. For example, we'll imagine that 1 to 100 kilojoules energy we want, we will imagine just 1 to 200 kilojoules energy we required to break the covalent bond. Then what about the hydrogen bonding? Hydrogen bonding, here to form a hydrogen bond even we required 1 to 50 kilojoules of energy. In case of van der Waals is a very weak forces. So nearly 1 to 10 kilojoules is enough for him. Okay, so 1 to 10 kilojoules is enough. So we can say hydrogen bonding is the intermediate of the covalent bond and the van der Waals forces. Van der Waals forces are the weak interactions. Easily we can break the bond. Okay, and hydrogen bonding, there is no independent existence. It has to associate with the covalent bond. Okay, so compared to, obviously in these three covalent bond is stronger because of high bond energy, right? So here hydrogen bonding, there is no chance of how much amount is you want, you can break the bond, that's all. But there is no other options in case of hydrogen bonding. Okay, so then another one, here we can say like what about the strength of hydrogen bonding? Hydrogen bond strength is bond strength is directly proportional to the electronegativity of the atom, electronegativity of the A atom. Okay, A atom. and inversely proportional to the electronegativity of B atom. Okay, and inversely proportional. Inversely means electronegativity of B atom. This we can say. So, because A atom's electronegativity we need not of requiring. Like here polar covalent bond it is forming. Electronegativity value will be difference when you are considering these two will be less than 1.7. But in case of these two, it is greater than actually. It's a more value is there. So, if a bond strength is increasing, electronegativity of the value that will be more. That is inversely proportional. We can say. Okay. And when you are considering all the like HF is the strongest hydrogen bond is there. Hydrogen fluoride is having the strongest hydrogen bonding. And when you are considering water molecule, you take water molecule. Usually water molecule, because of presence of hydrogen bonding, water molecule is existing in the form of liquid. Okay, if these hydrogen bonds are not there, like open band shape, right? 2 lone pairs of electrons will be there. These 2 lone pairs again, they are ready to join with another one. Okay, so one water molecule can forms 4 hydrogen bonds, 4 H bonds it can forms. Okay, so this is about the hydrogen bonding. Thank you all. Next, see the part 2 video. There we will discuss about the types of hydrogen bonding and properties of hydrogen bonding. Thank you.